questions. Here first question is from surface chemistry, in which it is asked about isobaric enthalpy of adsorption. Since this is isobaric, means pressure is constant, and here given pressure, temperature, so we have just used this formula. If you remember it, then you can solve it easily by putting all these values in this formula. So that is what I have done, and by calculating it I have got 5773.24 joule per mole. Now many of you may have done this wrong by writing just this answer, but if we notice that then in question it is asked in kilojoule per mole, so we have to convert it into kilojoule per mole, and the final answer would be 5.773 kilojoule per mole. It was just based on this formula we have calculated. Now next question is from RMS speed. This is super easy question. We have to just remember one formula, that is Vrms is equal to square root 3RT divided by molecular mass. Here first is Vrms of H2, that will be root 3RT upon molecular mass of H2, and second speed is Vrms of N2, that is root 3RT upon molecular mass of N2. Since here temperature is same, so we can cancel out the numerator side from here and put the value of Vrms H2 from the question. So we can write it as Vrms H2 upon Vrms N2 equals root 3RT upon MH2 upon molecular mass of N2. Now since the numerator will be cancelled out, so we can do it, and putting value of RMS speed of hydrogen divided by Vrms of nitrogen will give us molecular mass of nitrogen divided by molecular mass of H2. So here we can easily find Vrms of N2. Okay, 1900 divided by 2.28, and that is what we get after solving. It's 508 meter per second. This may be somewhat nearby answer, but this is the method that is used to solve it. Let's come to the next question, that is a dilute solution prepared by dissolving in non-volatile solute having freezing point of 0.180. Here we have to find out boiling point of the solution in Kelvin. Here we have to use two formulas, that is from colligative property chapter. Delta TF, first of all we have to write it 0.186 Kelvin given. Now we know formula of delta TF is Kf into molality. Now Kf is the chaoscopic constant that is given in the question, so we can find out easily value of molality. Kf is 1.86 into molality, so imply that molality equals 0.1. Now this molality will be used to find out the boiling point by using the formula delta TB equal to ebullioscopic constant into molality. Now this constant is given in the question here, that is 0.51, so we will put it here 0.51 into 0.1, and it gives us 0.51, that is delta TB. Actually this delta TB is the difference in boiling points, means after the elevation of boiling point there is difference. We represent elevation of boiling point by this term, means this implies that this is equal to 0.051. So TB is equal to 0.051 plus boiling point of original water, means pure water. So 0.051 plus boiling point of pure water is given here, 373.15 Kelvin. So we can add it here, and thus answer comes out to be 373.201 Kelvin. This is the boiling point that was asked. Next question is from quantum chemistry. This is also very easy question. We have to just find out sets which have same number of radial nodes. Now if we know the formula of radial nodes, then we can find out it easily. So radial nodes is calculated by formula n minus L minus 1. Here n and L values are given in every option, so you can calculate it easily. Here n minus L minus 1 is equal to 3 n minus 1. It comes out to be 1, and for this it comes out to be n minus L minus 1 0. So here we can see that 1, and here it is. So this option is wrong. Second is 3 minus 1, this comes out to be 1, and for this value 2 minus 1 minus 1, this also comes out 0. So this answer is also wrong, because here it has asked about two sets of quantum number having same number of radial nodes. So let's check option 3. It will be 3 minus 0 minus 1, that is 2. 2 minus 0 minus 1, that is 1. This is also incorrect. Let's check last one. 3 minus 2 minus 1, that is 0, and 2 minus 1 minus 1, that is 0. This is our right answer, because only in this option we have got the both sets of quantum numbers having same number of radial node, that is 0. Okay, it was a very simple question. Now let's come to the next question, that is from our chemical kinetics. This is also easier question. Here it has also order of the reaction and given half-life and concentrations of reactants. So we know that relation between half-life and concentration is T half a power n minus 1 upon a power n minus 1, means T half is inversely proportional to the concentration. Here n is the order of reaction. We have to find out this n value. Okay, so we will just take these two values, means T half 1, T half 2, and concentration first and second. So T half 1 divided by T half 2 equals concentration of 2 and concentration of 1 power n minus 1. Okay, now T half 1 is 360 and second half life is 450, and here second concentration is 4 into 10 power minus 2 divided by 5 into 10 power minus 2. Now this cancels out, this is whole power n minus 1. Now we get here 4 by 5 is equal to 4 by 5 power n minus 1. Now since there you can write it as power 1, so we can compare as n minus 1 is equals 1, and it gives us n is equal to 2. This is the order of answer. This is what we are required, n value. Now next question is from nuclear chemistry. If we know the formula of Q value, then we can solve it easily. Every question of physical chemistry was easier to solve if we know just the formulas of them. So here we can find out Q value by using the formula. Q value is equal to mass defect, that is delta M, into 931.5 mega electron volt. Actually this is asked in mega electron volt, so we have to multiply the mass defect by 931.5 mega electron volt. So here First of all, we have to calculate the mass defect delta M. This is the mass of reactant minus mass of the product. Here in reactant, this is hydrogen. It is given hydrogen nucleus have mass 1.007825, and we have to subtract it the helium nucleus that is from the product side. So there is single helium nucleus, so we have to just subtract this value 4.002604, and it comes out to be 0.028696. This is delta M value. You can put this value here 0.028696 into 931.5 mega electron volt, and it comes out to be 26.73 mega electron volt. That is our Q value. Now there may have asked about in the question that you have to route either up to 1 decimal place or 2 decimal place, that you know very well. This is the formula and solution. Here I have the last question. I have got a buffer solution is prepared by mixing 0.3 molar ammonia and 0.1 molar ammonium nitrate. Here ammonia is a base, okay, and ammonium nitrate is salt. We have to find the pH of buffer solution at the room temperature. This is room temperature. Kb is given for the base. We have to just use the formula POH is equal to pKb plus log salt upon base. This is the general formula used to calculate pH value of a base, that is ammonia here. So we will put here some values plus log. Now salt have the concentration 0.1 and base have 0.3 molar. So it comes out to be minus log 1.6 into 10 power minus 5, that is given here for ammonia Kb value, plus log 1/3. Now expanding this value minus log 1.6 minus log 10 power minus 5 plus log 0.33 value. Okay, now we have to put these values using calculator that I have done. It is 0.2041 plus 5. This 5 comes out the 4 log, minus becomes plus. That's why I have written here 5 plus minus 0.33. It gives the value 5 minus 0.5341 equals 4.4659. Okay, now we have to use another formula that is very general to all of us to find out the pH value. It is 14 minus 4.4659. It gives out the value of 9.5341. This is the pH. There may be some range in the final answer key. There was another question in which asked about BF3 and CH4 molecules. Which of them are microwave active and which are infrared active? So for microwave active molecules, there should be a permanent dipole moment. Okay, this is a required condition for a molecule to be microwave active. Now if we look at BF3 molecule, here since dipole moment is from electropositive to electronegative element, so here it comes out like this. Its resultant will be here. and here this will be from boron to fluorine. Now this value and this, they both cancel out, that's why dipole moment becomes 0. Similarly for CH4, since we know that CH4 is a tetrahedral molecule, means it have perfect geometry. So for perfect geometry molecules, dipole moment always becomes 0. That why both have 0 dipole moment. So both of these will be microwave inactive. But these both molecules will be infrared active, because for infrared active molecules there should be a change in dipole moment, change in mu value. So there may be change in mu value for these. Remember one thing, that only for homodiatomic molecules there will not be change in dipole moment, because they are just two, they are linear. We cannot change them by any kind of rotation. So for only homodiatomic molecules, infrared active, they are infrared inactive, and all other molecules will be infrared active. So these were some questions from physical chemistry section of IIT JAM 2021. I have solved some other questions too that was solved before. It was from solid state chemistry, that is calcium crystallized in FCC lattice of unit cell length 5.56 angstrom. Here it has asked about percentage of Schottky defects. Now to find out this value, percentage of Schottky defect, first of all we have to find this Schottky defect amount, means what amount of Schottky defect arises in this calcium crystal. Okay, so we will use the formula of density here and put all the values here. Here we have to remember that here for FCC lattice Z value is 4, but this is for original crystal, this is not for defected crystal that is asked in this question. So here in this formula we do not have to put this Z is equal to 4 value, but this is the Z value of defected crystal, means after defect. So we have to find out this value, and by putting all the values we can found out easily. Here I have done it. Z after defect is 3.842. Here we have to notice one thing, that since density is given in centimeter, so here we have to put cell length in centimeter too. Okay, we do not have to write only 5.56, but we have to write it as 5.56 into 10 power minus 10, and so we get Z value 3.846, which is after defect. Now since Schottky defect is only arises due to difference in number of atoms, so we can find it easily by subtracting from original to our after defect value. That comes out to be nearly 0.2, and now after that we can use the percentage formula to find out its percentage, that is Z original minus Z after defect divided by Z original into 100. And so now here gets, since this value was 0.2, near about 0.2, you can calculate it to the more accurately, and it gives us percentage Schottky defect as 3.9 something. This is the approximate value, and there in the final answer key there may be some range, so you need not to worry about that. If you have got answer as 3.8, 3.9, then it is the right answer. One more question was from photochemistry. Here it has asked about the molar extinction coefficient. Sum of values given here that I have written. Here is the solution's concentration as 5 millimole, cell length is 4 centimeter, and the light that passes through this compound is reduced by 90%. Here it is given in the question that it is reduced by 90%. So only 10% is transmitted, means transmittance is 10%, that can be written as 10 power minus 1. Now you can use this formula A equals minus log P to find out the absorbance value, that comes out to be 1. Now we can use another formula A equals epsilon Cl, from where we have to find the molar extinction coefficient. Okay, so we can get it easily by putting all the values, and it comes out to be 50 centimeter inverse per mole. Okay, here in all the physical chemistry questions we have to notice about units are. Here I have got answer in centimeter inverse, or mole inverse, centimeter inverse, and same is art in the question. That's why it is true, it is correct answer. Okay, so these were all the questions that I have got from some sources, and remaining question will also be uploaded in second part of this video. Till then, take care and do like and subscribe this channel if you like this solution. Okay.